Welcome to this week's challenge problem. We have a pretty tricky percent change problem on deck this week. So if you haven't had a chance to try this one out, give it a shot yourself, pause the video, give yourself as much time as you need. You can use a calculator if you'd like. So go ahead, pause it, and then we will review it. So let's begin with perhaps the easier way to do this, which is to plug in, pick our own numbers, and kind of go through the problem, see what happens as we increase this by a certain percent, and then figure out by what percent we need to decrease it to get back to start. So I'm going to plug in my own x here. I'm going to make x is 100. Just an easy number to work with percents. Easy to increase, easy to decrease it. So I'm going to start with that as 100. And I'm going to make p, again, I'm just a free choice here. I'll make p 20%. So p will be, so we've got to be careful here. So I want it to be a 20% increase, but the problem says it's increasing by 100p%. So if I want this to be 20, that means p has got to be 0.20. That's where this 100 is coming from. It's just making sure everything is consistent within the problem. So I'm going to make p 0.20. So first she's going to increase the size of her collection by 20%. So we're going to go ahead. We're going to increase it by 20% with 100. That's easy to figure out that that's 120. If you're not sure, we basically just multiply it by 1.20. And that 1.20 comes from 1 plus 20% as a decimal. So the question is, by what percent do I need to go back to start? Now, if you picked B, you probably thought, well, I just take away 20%. Right? I go from 120 to 100. I take away the 20% to get back to start. So it's like I'm just decreasing it by 100p%. It's a perfect circle, right? Unfortunately, it doesn't work. If you want, take away 20% from this and you won't get 100 again. I think you get like 96 or something. So that's not going to work. But what we need to do is figure out what is this percent that will get us back to 100. So let's call this percent, give it a different letter here. We'll call it y. So this is going to decrease by y%. So that means I'm starting with this number 120. I'm going to decrease it by 1 minus y as a decimal because I'm going to be decreasing it by a certain percentage. And I want to get back to 100. And so when I solve this for y, I'm going to find out what that percent is. It's going to be as a decimal, but it's fine, right? Because I've got my initial number. I'm multiplying it by 1 minus my percent decrease. That's what's going to decrease it, and we should get to 100. So 1 minus y is going to equal 100 over 120. So do some rearranging here. This is going to be y equals 100. Actually, it'll be y equals 1 minus 100 over 120. That's the same thing as 1 minus 5/6. So that's 1/6. And so keep it that way. We can turn that into a decimal if we like. But this is sort of the percent decrease. I guess we can find this percent decrease. What would this be? So it'd be 1 divided. It's going to be some annoying decimal. So it's 0.16 repeating. So about 16.6 repeating percent decrease. Okay. So how does this help us? Well, now what I can do, this is about 16.6%. I can go to the choices. This is kind of my answer. It's got to decrease by 16% to get back to the starting point. Go to my choices here, see which one gets me the same value. So with A, it's going to be 100 times 1 minus 0.2. So that's 100 times 0.8. That does not equal what I'm looking for. 100 times P we already discussed doesn't work, but we can see here clearly I just get 100 times 0.20, which is 20%. That's not the decrease. How about C? 100 times 0.20 over 0.20 plus 1. So this is going to be 100 times 0.2 over 1.2. So what's 0.2 over 1.2? Put that into the calculator. Aha, this is 16%. So this is the same thing as basically 100 times a 6 or 16.6% repeating. So this is looking good. We'll just check out D, not looking very promising, but we'll try it. So it's 100 times 0.2 plus 1 over 0.2 minus 1. I mean, right away, this is negative, so I can't have a negative here. So it's going to have to then be choice C. So that's one way to do it, plugging in. There's another way which is more algebraic, which is to kind of work with the variables, work with what we're given. So we know we're taking our x and we're increasing it by 100p%. So how would I actually make that increase using these unknowns here, using these variables? So x is x. That's the starting point. If I'm going to increase it by 100p%, then to do that, I'm going to multiply whatever x is by 1 plus p, because p would be some decimal, as we saw in the previous version. We picked 0.2. But the point is, this is going to be your percent increase. And I'm going to multiply it by x to increase it by that. So now what's going to happen, if I want to get it back to x, I'm going to have to multiply it by some percent decrease. Let's call that 1 minus y, where y is the percent decrease. And the end result is I'm going to get back to where I started, x. So what is this telling us? Well, if I do some rearranging here, do some simplification, those can cancel out. I'll move the 1 plus p over to the other side. I get 1 minus y equals 1 over 1 plus p. Let's solve for y, because ultimately that's what I care about. So move some things around. I get y equals 1 minus 1 over 1 plus p. This is the same thing if I multiply this by 1 plus p over 1 plus p. This is the same thing as 1 plus p minus 1 over 1 plus p when I combine. This cancels, and I'm left with p over p plus 1. So here is the percent, or the decimal form of the percent. I'd have to multiply this by 100, as we see in choice C, to make that decrease. So this is the y. This is that percent decrease that we originally had. And when we kind of work through the consequences of that, we find that the percent, at least the decimal form of the percent decrease would be p over p plus 1, which we then multiply by 100 to get back to a percent. And so that is also choice C. There's another way to do it, which is kind of related to the first way we did, well, the second way we did it. So again, we'll start with x, and I'm going to multiply it by 1 plus p, again, because I'm increasing it by that p%, or that 100p%. So if I want to get back to x, one way to think about this is, what would happen if I multiplied it by 1 over 1 plus p, right? Just mathematically speaking, cancel, I'm back to x. So one way to think about it is if I multiply my result here, my new number, by this term 1 over 1 plus p, I get back to start. So we kind of explore this and figure out what is this. So this is not, as you can see, it's not in the form of 1 plus or minus some value. So it's not a percent decrease or percent increase. But basically what we're doing here is we're multiplying this by some percentage, right? We're multiplying it by whatever that is as a percent to get it back down to the starting point. So let's say, this was, 75%, if that was a real number. If I'm multiplying this by 75%, what does that mean? It means I'm decreasing it by 25%, because those ideas are flip sides of the same coin. So that means if I want to turn this into a percent decrease, what I can do is just rewrite it as 1 minus 1 over 1 plus p. Because basically whatever percent that is, I subtract it from 1, and that will tell me the percent decrease that it represents. And I think this is actually literally what we just got. If you simplify this again, you get p over p plus 1. So there's a lot of ways to do this. If you see any other ways to do it, feel free to leave a comment below, or just reach out to us otherwise. But these are some ways to do it. At the end of the day, what's tricky about this one is, well, keeping track of the variables. The 100p is sort of weird. Not falling for the trap of going up 100p% and thinking you can go back down 100p%. But I think ultimately the best way to do it is plugging in. It just makes it real. But you can also do it algebraically. And I think if you understand the intricacies of this problem, there's nothing the SAT can throw at you in the percent change realm that will trip you up, because this is way harder than anything you'll see on the real thing. So that's it for today. Let me know if you have any questions. Feel free to leave a comment below, and we'll see you next time.